12.3, students will be able to find mean, median, mode, and range. Essential understanding. You can use different measures to interpret and compare sets of data. So for mean or average, please feel free to pause and write this down. The mean or average is when you add up all the data values and divide it by the total number of data values. For median, feel free to pause and write this down. The middle value in a data set when the data values are in order. That's really important. Put them from smallest to largest, left to right. Mode, feel free to pause and write this down. The data value that occurs the most times. There can be more than can be more than one mode or no mode. So it's just what number or numbers or qualitative data or words show up more than once. An outlier is a data value that is much greater or much less than the other values in the data set. So an outlier is usually like, let's just say most students got between like a 60 and 100 for a test, and then you had a kid that got like a 15%. So the 15% would be an outlier. Their grade is much farther, much lower than a normal person. So for example, if I had the numbers 20, 25, 30, and 6, the 6 would be the outlier because it's much smaller than 20, 25, and 30. All right, take a moment to write this down along with this and along with this. Actually, I'm just going to let you write all of them. So when is it best to use mean? So let's just say there's no outlier. That's the main part. If there's not an outlier, it's best to use mean. So I actually, with test averages, I wish they didn't do mean on Canvas. I wish they would do median. This is the best way to describe data when something does have an outlier. So like, for example, like when I said if a person has a 15%, but everybody else got like C's, B's, and A's, that person that got a really low grade, they're going to bring down that average by quite a bit. Mode is when the data is non-numeric or when choosing the most popular item. So if I polled 5 people and 3 of them said their favorite ice cream was chocolate and 2 said vanilla, that means chocolate would be, the mode. And we would use mode to describe that for that's the best way to describe that data for central tendency. All right, finding measures of central tendency. Please change this to Bowler 6, Bowler 7, and write down mean and median. So it says, what are the mean, median, and mode of the bowling scores below? Which measure of central tendency best describes the scores? So we've got 8 different bowlers with their scores. To do the mean, we're going to add up all 8 of those numbers. That's where they're listed up here. Feel free to pause at any point. We're going to divide it by the total number of data values, which there's 8 bowlers, so we're going to divide it by 8. You can do this whole thing in your calculator. Make an actual fraction. Put all those numbers in the numerator with addition signs and 8 in the denominator, and you're going to get 122. The mode is the number or numbers that show up the most. And the number of numbers that show up the most is 104 because it shows up 3 times. For median, here, hold on. For median, you need to order all these numbers in order from smallest to largest, left to right. And then we're going to cross them off at the end. So I'm going to cross one off here, 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 one off here. So I'm left over with 2 numbers because there's an even number of data values. When that happens, here's what you're going to do. Draw an arrow. You're going to add those 2 numbers and divide it by 2, or take the average of those 2 numbers, which is 111. Number 2, your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? So first of all, there's 4 exams. On the first 3, you got an 80, a 93, a 91, and we don't know what the 4th exam is. That's what the question is. That's why it's an X. Over the 4 exams, that's going to help us find the average. And then it's going to be equal to what we want for the average, which is a 90. So there's more than one way to solve this, but what I would do is I would add or combine the like terms on the top. Still over 4, still 90. And then to get rid of this denominator of 4, I'm going to multiply the entire equation by 4. So when I multiply this side by 4, the denominator of 4 goes away. When I multiply the 90 by 4, it equals 360. Now I can solve for x by subtracting 264. On the fourth exam, I'd have to have a 96 to get that goal of a 90 on the 4 exams. A measure of dispersion describes how dispersed or spread out the values in a data set are. One measure of dispersion is range. The range of a set of data is the difference between the greatest and least values. So number 3, finding the range. The closest prices in dollars of 2 stocks for the first 5 days in February are shown below. What are the range and mean of each set of data? So first we got the prices in dollars of this stock for the first 5 days in February. So it says, what are the range and mean of each data set? So for the range, I'm going to subtract the smallest number from the largest number, or 47 minus 25. For the mean, I'm going to add up all of those numbers and divide by the total number of data points, or 5. The mean is 32. Feel free to pause and try to find the range and mean of stock B. For stock B, I'm going to add up all of these numbers and divide by the number of data points there, which is 5. The mean is 32. For the range, I'm going to do the largest number minus the smallest number, or 36 minus 28 to get 8. If I were comparing the two, I'd just say that stock A has a larger or more spread out data value because the difference between the largest number and the smallest number is 22 compared to stock B. So you could say that this stock, the closing prices vary a lot more than stock B. And then we could say that the average is the same for both stocks because they're 32. Okay, so this one is really confusing every time I've taught it every year, so feel free to pause, rewind, whatever. The results of a survey on the number of televisions in student households are shown in the line plot below. So first of all, for line plot, this is number of televisions per household. So all of these X's represent people. So we see that, 2 people have 1 television in their home. There are 4 people that said they have 2 televisions in their home. 6 people that said they had 3 televisions in their home. It says calculate the mean, median, and range of the data. So for the mean, I'm going to put 2. So 2 people said they had 1 television. Or I can do 1 times the 2 people plus 2 times 2 televisions times the 4 people plus 3 televisions times the 6 people that said they had it plus 4 televisions times the 4 people that had that said that, and plus 5 televisions times the 2 people that had said that. All divided by the total number of people that were polled, or you can just count up the X's, which is 18. That in your calculator would end up being 3. Okay, now for the median. This is kind of weird. This is the difficult part. I am going to cross them off until I get to the middle. So, there's more than one way to do this, by the way. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, 1, 1, 1, 1. Okay, so I end up with between these 2 people, but I know that it's just 3. For the mode, which value shows up the most, that would be this, because there were 6 people that said they had 3 televisions per household. For the range, my highest number is 5 minus my lowest number, which is 1. That is 4. Okay, the results from the same quiz given to 2 different classes are shown in the line plots. Which class has more students in the top half of the quiz scores? Again, this one is difficult. It's difficult to, grasp. So, which class has more students in the top half of the quiz scores? We want to think, how many students are above the median? Because the median is the student, the middle value. That's going to separate the top half of the class from the bottom half of the class. So let's try to find the median first for class A. So the median, I'm going to cross off one at a time. Oh, I'm left over with one data point of 3 and one data point of 4. So that means I'm going to have to take the average of 3 and 4, which is 3.5. Let's do that for class B. This is where it gets tricky. And we're left over with 5. Okay, so now for class A, I'm going to look at how many people are above the median of 3.5. Well, technically, this is where 3.5 is because this is 3 and this is 4. So for 3.5, I'm going to count how many people are right here, how many data points there are. There are 13 data points. For here, this is my median. I'm going to count how many people are above this median. And that is 6. Because it's 1, 2, 3, 4, 5, 6. Oh, shoot. 1, 2, 3, 4, 5, 6. Well, let me see if I messed up on this. We've got 1, 1, 1. Okay, so that's 1, 2, 3, 4, 5, 6, 7. I think it's 7 actually, not 6. Okay, so we have more people. Sorry, what does it say? Which student has more scores in? Which class has more students in the top half of the quiz scores? And that would be not that one. This right here, class A as our answer. And then B, it says, by comparing line plots, how can you tell which mean is greater? Well, if I were to erase this, so which mean is greater, that just means which one has a higher average. And I know that the average right here is more towards the middle because there's more data values towards the middle. And for class B, I see that there are more students that have a 4, a 5, and a 6. So it's class B. There are more data values on the right side or with the larger numbers.